Hello everybody and welcome back. In this episode I'm actually going to do a lesson on how to install the hydraulic hard lines and get them ready to receive soft lines. And I've done this in previous videos before, but it's always been in sections. I've showed you guys a little bit of the way to do it, but I've really never done a start to finish. So that's the goal of this episode today, is a full-on start to finish on how to install the hard lines on these and then make them ready to receive soft lines. So I'm going to go over the materials and tools here first, and then we'll get cracking. So starting from the left here, I have some 5mm tube. The actually 5.5mm tube. The inner diameter of this tubing is 4.5mm. The reason I've chosen that is because I'm going to cut collars off of this to act as the rings that are going to go around the outside of the hydraulic cylinders, which I'm going to solder the hard lines onto to hold everything in place. I have next a bit of 1.5mm tube that is going to receive the 1mm wire that we have here. And then I have a 1.19mm tube, which the inner diameter will receive the 0.8mm brass rod, which I'm using as the hard line that will run across the tube, and then a little strip of brass, the thickness of which is the same as the wall of this tubing. This is going to be part of what holds the bracket. I'll get to why I chose this 1.19 in a minute. And then I have some solid core wire. Now this is the biggest question I see online all the time, is like, hey guys, what kind of hosing should I use for the project that I'm going to do? A very entry-level thing to do to try to detail a model is to add hydraulic hoses to it. And I think the easiest one to work with is this stuff right here. This is plain black solid core. That's the key component, is the solid core. It's easier to remove, and the outside diameter of this is 1mm, and it's nice because it fits inside the 1.5mm tubing, but we'll get to that a little bit later. I'm not going to actually install this stuff on the episode, but I'm going to show you what you need to do to get it installed. And I have a X-Acto blade here. I have it's a combination blade and small tool holder. I have a 1mm drill bit in there, and then I have a triangular shaped file. So if you were to look at it head on, it's a pyramid shape. One more thing I forgot to mention, 1.59mm square tubing. Using that because it will allow the 0.8mm tubing to slide into it. Now the first thing we need to do is to figure out where the inputs for the solid lines or the hard lines that are going into the hydraulics are going to go into. This is where your reference photos are going to come into play, and then you're going to need to mark it out. Even though it's black, a lot of Sharpie type pens, these ink felt tip pens, will actually show up on it. Get some better light here. Let's just go ahead and mark that out. I think I'm going to go with, I'm going to use this collar as my lead point for my measurement. And I think I'm going to go 2mm back. Just kind of eyeball this guy out here, follow it back over. 2mm. Make sure you're drilling on the side that it's supposed to be receiving it at. Now before you go drilling any holes in here, make sure you take the cylinder out. This hole is going to be pretty shallow. It's only going to be as thick as that outer wall, but a thing you can do to find out if you can actually drill the hole all the way through is install the hydraulic, put the component together that you're installing it on, and stretch that component out to its max, to where the hydraulic extends all the way out in the posed position, and then mark it. And then when you take it out, you'll see how much hydraulic piston is still left inside. And then if you want, you can figure out if you actually need to have all of that on there. Now this one is unique in that the cylinder is a lot longer than the piston. The ram is a lot longer than the cylinder, and they do that probably because they weren't able to get the geometry perfect on the model, and it just gives it a lot more support, and then when it goes back it still has plenty sticking out. And then when you extend it all the way, it doesn't bottom out, or not bottom out, but come out of the cylinder and then like make the model fall apart. So if you want for that rear hole, you can drill it all the way through, so long as it's okay that you don't have the end on there to stick back in all the way, if that makes any sense at all. So it would be able to go back all the way, not touch the back of the cylinder, and still function as it should, allowing you to run more of the hard line down into it after you've drilled the hole and give it a little bit more retention. I'm not worried about that on this one because I'm going to have a collar installed, and that is going to hold the hard line in place. It's going to be glued in, and then it's going to be on the inside portion where it's not really going to be exposed to any fingers when I'm manipulating the model to pose it, and it doesn't need to get drilled out that way, but it's something to keep in mind. I did that with the ones that get installed on here. Let me grab those for demo's sake here. So these guys have a hole that goes in much deeper, and I can put the hydraulic cylinder back all the way without touching the piece of brass rod that runs all the way through here. So I get really good retention for this tiny short little part. It's not glued in right now, but not glued in, I could show you guys. So it goes in a little bit deeper and hits the opposite wall. It just gives me a little bit better retention. Alright, so I've drilled the holes in here. Now I realize that not everybody has the luxury of a micro drill press. So you could do this the very easiest by hand with a little drill bit and then a little hand driver. Just be careful when you're doing it to not stab yourself in the finger. So maybe take like a little pin or something and create like a little divot to start the hole, and then work in there with the drill bit. I'm not going to use this one because it's a little bit bigger than the hole that I already drilled. You can also use a Dremel, or you can use a drill gun. Just be careful to not punch through unless you intend to actually punch through. You're only going through about 1.5 millimeters of plastic there. And then I did the one in the back. The next thing I need to do is cut my collars. Now I'm going to use my little miniature chop saw. The other option you can use is one of these. This is just a miniature pipe cutter. The only thing I don't like about these is that it leaves a little bit of a lip when you first start your cut. Now that could be because the blade on mine is a bit dull, but it's just something to be aware of. You can see on this one I did use the pipe cutter, and it did create like a little bit of a beveled edge there, which I'm not the biggest fan of, but it's better than nothing. And then the other option would be to get a little miter box and a razor saw. And if you don't know what a razor saw is, it's one of these guys right here. You'll find them in just about any hobby shop, and they even have a kit that comes with the miter box and the razor saw. But I did find with my miter box the guides were off just a little bit. So I'm going to go ahead and cut out this for this particular one, just because of the design. I'm going to be using this as a bracket later on in this build. So I want to make sure that this is the same thickness as this one. So if you're going to be installing a bracket on there, make sure you make your collars the same size. Alright, so another thing that I should probably mention, once you've made your collars, you'll probably need to clean the cuts up a bit here. I have what's called a rat tail file. It's just a round file with a spiral pattern on it. And I'm just using it to clean up the flashing on the inside of this barrel. Then if you have a sanding stick small enough, you could get in there with it and clean it up a little bit more. Then clean up the outside as well. You want to make sure you just get that nasty sharp edge off of there, because when you paint it, it's really going to stand out if it's not clean. Now if you're lucky, the collar you cut will slip right over the hydraulic. That's not the case here. So I'm going to need to put a cut in it. When you do this, remember to orient it so that that cut is in a position where you're not going to see it when the model's assembled. So we have this other one here that I already built. The cut is on the bottom. So when it's installed, I'm not going to be able to see that because it's going to be hidden. the hydraulic will never come up enough. So the same thing is going to need to apply for this one. The cut in that hydraulic cylinder is going to, or not hydraulic cylinder, but collar is going to face the boom where it's going to be least visible. Now there's a number of ways you can make that cut. You can either install it in a vise and then take your razor saw and cut down through the top, or you can use a pair of side cutters like this one and cut straight across. Trying to make sure I line it up straight. Pop. Now I'll see if I need to reduce it any. You're probably actually going to need to open it up a little bit too. Just a bit. You kind of press it back in place later if you need to. So I can see that the color is just a little bit bigger, so that means I'm going to have to take a little bit of material out of that cut. Now these cutters have a flat side and an angled side, so find the side that's already flat and don't cut that one off. Cut the side that has the angle to it off with the flat side of the cutter. Just makes a little cleaner result. So cut a little bit of the collar out there. Go ahead and install it back on. And now I can crush it together and see if I need to remove any more material, which I do. So go back and take a little bit more out. Looks good. Alright. Pull that guy back off there. So now I'm just going to give it a little bit of a crush so that it doesn't have as big of a gap anymore. It will allow me to retain it on there better. Now I don't need to worry about gluing this onto the plastic here, because once I install those lines, they're basically going to hold it in place, and because they'll be soldered to it, the whole entire thing will just kind of keep itself in check. Now for the input portion, and this is a spot where you can add this extra detail or not, I'm going to slice a very small bit of this square block, and that's going to be where the hose is going to input into the hydraulic. I'm doing it with the square block because it looks the most realistic. Now what you can do if you don't have the square tubing or the means to make an even cut with that, you can just use the wire straight up, and you can just take and do a 90-degree bend and have it go directly into there. It will look more realistic than nothing at all, but for this model, since I've already added so much detail everywhere else, I want to make sure I add that bit of detail as well. So I'm going to cut a small little piece of this square, and after that part then we'll get to bending the wire. Alright, so now it's wire bending time. I have the two blocks cut. On one side I have a little tiny hole drilled into it, and then it has the hole that's already inside the square tubing. Just kind of mocking up where it's going to go. Move this guy out of the way. We'll work on the top one first. So because this is a boom cylinder, it has the hose that goes in on one side, and then it has one that goes in on the other side, which means I can't do a common rail much like I did with this one. See how it has an independent one, and then it just has one fitting that comes out. This one actually has two hard lines that run to the multiple soft lines. So the first one I have to bend, and I'm going off of reference photos for this, so whatever model you're working on, you'll have to look at the reference photos to figure out the routing. But it's basically got a bend right about there. So it plugs in, runs, goes at an angle, and continues back to the block where it starts from, and it's actually got another little bend right there. And then the second one has a full 180 loop, and then it runs up and over and drops into the back. So it's kind of an advanced, complicated bend. But you could probably do a simpler design if you wanted to, especially if you weren't being OCD about the accuracy like I am with this one. And for bending, you can use just a simple flat pair of pliers, like any pair of pliers with a smooth surface on them. Or if you want to get a little bit more advanced, you can use something like this. This is a half-round bird beak. And they've got multiple different names for them, but it's got a squared off beak on it, and then it's got a round beak. Alright, we're going to change tactics here because this isn't working, trying to hold this and figure out how this is going to orient itself in here and then bend it out. So I'm going to do some of the soldering now. I'm going to install the little piece of brass that's going to connect this block to here. And I'm going to drill a hole through it so that it can accept this, so that I can kind of hold it in place and then figure out where I need to bend this to. Additionally, I'm going to take and solder the bracket onto this little collar here, the same bracket that this other end is going to rest into. And that will give me a little bit better idea of where I need to bend this stuff to, because trying to like visualize where the bend's going to go is kind of frustrating me. And there is another really basic thing you can do to kind of help you figure out which direction the bend needs to go, and it's kind of tougher on small wire like this, but you basically, kind of like I did right here, you do the mark on the side that the bend direction needs to go. So you would put like a little dot right there, and that would indicate to you that you need to bend it this way. But again, I'm really doing myself a disservice by not having my reference point, the bracket, already put together. So I'm going to do that, and then we'll continue on. So we've got the side of the block here. That's the part that the shaft is going to go into. And then you can see, let's roll that over. And that's like the entrance of the square tubing where the part that runs along the length of the cylinder is going to go into. So I've been noticing with my flux, I'm getting like these little crystals in there of like dry flux. Does anybody have a suggestion for how to either keep that from happening or to get those crystals to go back to normal? Do I just need to like hit the flux with a heat gun and just kind of like re-liquefy it and then let it cool? I feel like that might be a good idea, but it could also potentially ruin an entire tub of flux. So one of the reasons that I have this triangular file is when I make my little slices of these tubes, you might be able to see it, but the edge of it kind of rolls over and makes the inner diameter not as wide as it should be. So I just take the tip of the triangular shaped file and then just kind of use it as a reamer, and I rotate it to take that extra little lip off of the edge of the tubing. So it makes it easier for running things through it when I need to. Alright, so this is soldering setup number 2. Both of these came out the same way. The little L bracket soldered to the ring, but the little tubes didn't solder to the L bracket. Not sure why, probably has something to do with heat. And all that black stuff that gets burnt all over it, I believe, is the flux. It just goes up in flames. So I've set up another one here. It's probably kind of difficult to see because of the camera's perspective and the light. I apologize for that. But I have rigged up a bunch of pins, and I have the tubes through the pins, and then the little L bracket here, 2 tubes, and then a little bit of solder in the middle. So I'm going to try to heat it, and hopefully it doesn't all come undone. I do believe it should stay in place as long as I don't move the L bracket or bump this alligator clip. I basically have the alligator clip grabbing the circular part, kind of like if you threw an orange into an alligator's mouth, and everything else is rigged up, so hopefully it doesn't go too nuts. Let's find out if this is going to work. I might need to add a little more solder to that. Let it cool and see. Yeah, so it's gonna need a little more solder. Fuck, what the heck was that? That was weird. I don't know why I did that. I think it might have slipped inside the alligator clip. I think that's what happened. Alright. Let's try to doctor this up and fix it. Yeah, I think when I was heating it, it heated up the part within the alligator clip, and then it popped loose and made a jump. Alright, much better. So a little example of sometimes having to change it up a few times in order to figure out the right way to get something done. Just because you rig it up and it looks good doesn't always mean it's going to work that way. So better part of an hour spent figuring out how to get this done in such a way that it would stay together. But I now have one completed piece, and I just needed to do the other one. Yes sir, yes sir. Will work. Just finished soldering the other one back together. I think this will do. Alright, I'd like to apologize in advance for the landscaping noises outside. Don't always have control over what goes on out there, so just gonna have to deal with it for right now. But we're back where we want to be with this. I have the bracket installed just so I can use it as a reference point, and it's time to start bending the wires back in the directions that I need them to go. This is actually a lot easier having this installed on here because I can figure out what I want to do now. But first I need to figure out some measurements for bending, just so this stuff is a little more uniform. And actually I'm probably just going to bend this one up and then take it off, and I will bend up the other one next to this one. So let's go 5 mil, make my first bend right there. Alright, made the second bend. Pretty straightforward, just kind of canted it off to the side here, grabbed it and made the bend. I also took and made this bend a little bit more steep, just so that the two bends would look similar. I need to bend it back towards the pipe. So it's going to go in the same direction as that one. Uh-oh, that's too much of a bend. Same direction as the other one, Steven, not that way. Alright. Okay, dokie. I think that'll do. Let's clip it. Wait, I see something I don't like. Alright. Now I'll shorten that a bit more later. I just did it that way for right now. Very cool. So number 1 is installed. I just need to make the second one. Alright, so this next one bends in 180 degrees and then it comes back to meet up with that input right there. So I'm going to do the bend first. It's got to be as thick as the hydraulic, so that's almost all the way back, I think, to about the middle point right there. So I figure out how much lead that I need on it. I should give it about that much. I can cut it later if I want. Then wrap it around. A little hook. Alright. It's like a trombone. Alright, I took a second look at my reference photo, and it actually doesn't close the loop that much. It's a little more open, so grab it here and roll it back out a bit. And I couldn't imagine how difficult it would be to do this without like the internet, because I can just go online and look up photos of machines, either for sale or ones that people who do machinery photography as a hobby have put up. But like, this was back in the day. I'd probably have to find a local dealership that had one of these available, and then hold on a second. Alright, that had one of these available, then come out, see if he'd let me take photos of it, and then hope that I got enough photos of all the parts that I needed to work on. But I think we might have nailed it. Stop moving this thing around. Clip it like right there. Alright, that worked pretty well. I like the way that came out. Pretty sure that's how that goes. I have one photo that's like looking in at this direction, and I can see the little Z bend at the top, and then my other reference photos are straight on like this, and I'm able to see this bend. So I think that's pretty accurate. I'm sure it's not exactly accurate, but it's pretty accurate. Alright, all the wire bending is done. Now I need to make the collars, or the little connectors that will go on the end of there, so that I can eventually attach the soft tubing. But these came out pretty good. They look like musical instruments. Alright, so now it's time to create the little coupling points here that are going to go into here. Coupling points that are going to go into here. And I will be trimming these back eventually, but I don't want to solder them in place because I've already got all these other solder seams there, and I don't want to break all this stuff loose. So I've taken a T-pin here, and I have placed the 1.19 mil and then the 1.5 mil tubing on there, and I've actually taken the end of the 1.5 or the 1.19, and I've kind of beveled it in a bit, and then I took the inside of this and tried to cone it out just a little bit, but it creates a decent little seat. Alright, the fitting is complete. Let's do a test run here. Cool. It is on. When you're doing this, try to cut with the part that's coming off towards this finger. Whether you're lefty or righty, you want it to go towards the fingers so that you can capture it after you make your cut so it doesn't go rocketing out. So as far as the soft lines go, this is the part that is the biggest mystery that people seem to not be able to find exactly what they're looking for. I think this stuff works the best. Let's use this one because it's not cooperating. So, there we go. Ooh, that worked really, 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 really well. All right, both of these are seated in the same position. You can see, you can actually just get that hose right in the back there. Now you can see that the line is rigid, right? Not everybody may want a rigid line. When would you want rigid lines? Probably when you're gonna maybe pose a curve that's never gonna move. But the easiest way, and I don't want to waste this crap, but let me just take a length of it. All right, so I've got a length of this cut. Take and pull a little bit off the back. You can see I have a solid core in there. Grab the core, straighten it out as much as you can, and then just use your fingers, and from this end, don't pull from the other end because you'll just snap it, the tubing, not the wire, and just pull the wire right out. Now you're left with this tubing. Now you can try to glue it back in, and it might work, but because it doesn't have anything inside, you're not getting that rigidity you need to slide it back into the 1.5 mil tube. So what I like to do, take it from the wire, bring it back out, take and slide just a small, let's use that other end because I think that's the clean cut. You know what? Let's create a new clean cut real quick. Alright. A little bit to open it back up. Take and slide a little bit of that back in there. Got about 2.5 millimeters of it in there, I think. Cut it. Grip it, either with a pair of pliers or soft tweezers, or your fingers, and then just kind of tease it back in there. Sometimes I can do it with my fingertips, sometimes not. Alright, it is inserted back in there. So you would be able to glue that in place, and you still get the flexibility that returns back to where it wants to. Gives you that realistic hose-like, but you are left with a fitting that stays on. So that's how you do realistic, or at least that's how I do realistic hoses. So if we get this guy back on there. Oh yeah. Alright guys, so I hope that gave you a basic idea of how to get this done. Again, I'm not the authority on this stuff. This is just the way that it works for me. I'm sure I will improve my methods over time as well, but that's how you get a really nice detailed result on there. I mean, you could go super simple with this, but I mean, let's look at this and try to see what we can do to make this a simpler one. If you don't want to go with as much detail, you can eliminate the blocks and then just do rounded entryways into the hydraulic. This ring you don't necessarily have to do, or you can do out of plastic if that's what's available to you. And then these fittings, if you want. The reason I had to stage them is because I did a 0.8 for this instead of a 1 mil. If I had done 1 mil, I would have been able to just go with this. Let's see if I have another one that I just did 1 mil on. For this guy, I went with 1 mil because it was a longer distance, so I thought it would look good over a longer period of distance. And then I got the, again, 1.5 mil on the back, but that looks much more scale. If I had just soldered that directly to the 1.8, I don't think it would look as good. And I'll use the same method for the hoses on this one, and then on my other one as well. This one I just didn't put the fitting ends on yet. I will later. This is 1 mil also, and then this is 1.8. And there are 0.8, I'm sorry. And the reason I went with 0.8 on this one is to... You're rambling, Steven. Alright, so that wraps up the episode, guys. I hope you enjoyed watching this, and I will get with you next time. Adios.